Hello everyone and welcome to today's video. So if it's your first time joining us in these videos, I just want to give you a brief overview of what we are trying to achieve here. This is a series which is ongoing and it's going to go for I think quite some time, where we are trying to, or where our goal is to implement a microservices-based social media application. Maybe in production, maybe in the real world, the decision for microservices or for a monolithic application is a somewhat harder decision to make. It's not just, I will go to microservices, I will go with monoliths. We should understand the dimension of the problem and our initial goals. But for our purposes here, which is solely and mostly for learning, microservices is going to provide us a lot of new things to discuss. Everything that we discuss in microservices is somewhat applicable to monoliths, in the sense that microservices add an additional layer of complexity, especially when communicating between microservices. So the goal of this series is to discuss the many topics involved and to provide a couple of solutions and practical coding examples. With that in mind, if you didn't check the previous videos, I would recommend you go to the beginning of the playlist and go through the videos that interest you. Otherwise, you can just check out the code from Git and you can follow this video if you just go to the previous video and get the commit. So I post a specific commit of the code at the end of each video, so you can get the code from the last video as the starting point. There is some setup required, but nothing more than just running some npm install and some probably troubleshooting a few setup issues, but then the code should be fully working. With that in mind, our goal for today is to implement or to start the implementation of password hashing, right? So encryption, actually password encryption. So I already moved this task here in progress, and let's go back to our code and we'll start writing some tests for our user. So at the moment we have tests for the user creation. We want to make sure that we cannot create a second user. This is the only test that we have for the user model, that it should not save a new user if the email is already in the database. And now I want to write a couple of new tests, and here I would go a little bit beyond just making things fail and stopping everything. I want to write all the tests in this video, and in the next video we will work on a new class, a new password hash class that is going to be responsible to make this functionality work. So it should hash the password, or it should encrypt the password when creating the user, right? This is going to be an async function because we need to create the user. And here we will simply say const new user is going to be equal to await user.create, and here I would like to have the user info, but the user info is not available here because it's within this it statement, so I'll just move it outside. We can also wrap everything in a I don't know why they import user info. So we can also wrap everything in a describe statement, which would be tests the user model, the user mongoose model, and we could cut and paste everything within this describe statement. Maybe for the future, as we have in the sign up tests here, so in the sign up route, where is it? Here, in the tests, we have a couple of different describes, right? So we have a test sanitization, a test saving the signed up user, and here we have sanitization of input, password, email, password, and then validity of email and password. So if we have more test cases in the future, then we could also wrap them in a describe command. So now that I have my new user, the first thing I would like to do, I would expect this new user.password.not to equal the user info dot the password, right? So I don't want these two passwords to be the same, because that would mean that they are not correctly, that the password is not correctly hashed, right? It's not correctly encrypted. So this first thing I want to do, and of course here the tests will already fail because the two passwords match. But what I also want to do is I want to expect, so my password, it should have two different parts. It should have a part which is the hashed password. So normally an encrypted password, it looks something like this. So encrypted password. Maybe in the next video I can give you an overview of how the encryption algorithms work, but maybe that's not relevant for us because we will not implement our own. We will just use the one that is provided with Node, and it's secure enough according to all the standards that are out there. So the encrypted password is going to look like not only letters but also numbers, yeah, and this would probably be hexadecimal, so no letters bigger than F here, and then we would have a dot, and we would still have something later here, right? So this would be the hashed password, and this is the salt that is used to calculate this hashed password. So this would be the way that we would store the encrypted password in the database. So if I come here to my new user.password and I split it in the dot, right, then I would expect this to have length of 2, which means that I would expect this password to contain these two information for us here, right? And the last test I want to do is something that maybe will become clear as we implement the actual encryption mechanism. But once I split and I take the last element of this array, so this element here, I would like it to have a certain property, right? And this just for like sanitization issues, or like just to ensure that I have consistency when creating the salt for my encryption algorithm. So I want this to have, so I want this, the length of this, to equal the length of a random bytes string of 16, of size 16 to hex, and I will explain you in a bit. And this is going to be to the length method. So what am I doing here? Well, the only thing I'm doing, and this probably doesn't add a lot of value, but it's a quick test to make, just to ensure that if I change the size of some random byte generation, then this is not allowed, right? I'm not allowed to change this because it could be the case that I want to reduce. I don't want to reduce this. So I want, or I could even make like to be greater or equal to this 16, but for our purposes 16 is the size recommended by the Node website, so by the crypto library from Node. So we'll go with the recommended size. If I come here to the random bytes, then unfortunately this doesn't give us any documentation about what it does, but just to give you some brief explanation, what this does is generates a random bytes of size 16, right? And then I can transform these random bytes, so this buffer, to a string using the hexadecimal encoding, which means I will end up with a string that looks something like this, a few letters and numbers. And I want to make sure that I'm using the same algorithm to generate a new random bytes whenever I am saving the user. So I want to ensure that the length of this stored salt string here is the same as some new string that I'm generating from the random bytes, right? So this, I will remove this here, and this last test is just a sanity check, not much value added. Also because it's quite hard to really test encryption, right? How do we ensure that the encryption works? Because it's a somewhat circular mechanism. Because I have the salt and because I have the hash algorithm, then it doesn't really make sense for me to take the created hash and undo the process, because I'm the one who is making it in the first place, so of course the test is going to pass. Of course the decrypted password is going to be the same as the original password, because I'm the one in control of this process. So testing the hash of the password or the encryption of the password would be more in the sense that we would like to test that the encryption function is actually strong. But this is very complex to check, so we cannot do that here. So what we will do is we'll trust that Node's implementation of it is following the industry standards, and we will use script. I can just show you here. All right, there is a crypto library that is provided with Node, and we can just look here for script. There you go, can be sync or something. Provides a synchronous script implementation, so maybe this in Wikipedia you can find more information about it. There is no, so here they explain exactly what are the processes, right? What is the process, what is the algorithm behind, and you can get a very nice overview of the topic. For our purposes here, let me go a little bit above. So we have both script and script sync. So the first one is an async function, and the last one is a synchronous function. Now the idea is that this encryption can take a lot of time, right? If it's a long encryption algorithm, then it can take a lot of time, or a lot of iterations. This can last from minutes to hours. So we don't want our entire request or our entire application to hang while this encryption is being run. But because we are working with relatively small strings here, up to 32 characters, and we are not putting a lot of iterations, we are going with the defaults, then we will actually use the script sync to begin with. And I don't see a big problem with this. If it turns out to be an issue in terms of performance, we can simply revert to using the async version of script. And this is, so script is a password-based key derivation that is designed to be expensive computationally and memory-wise in order to make brute force attacks unrewarding. So as you can see, it's expensive, right? It's an expensive technique. But if we were to, why can't we use the asynchronous here? It's because we need to eventually save the user to the database. And to save the user to the database, we need to have the result of the encryption. So we need to, in any case, either call the script, the script sync function, or we need to await the result of the script async. So both are the same, and so I don't see a reason for us to really use the script async function. So here is the recommendation, right? The salt should be as unique as possible. It's recommended that a salt is random and at least 16 bytes long. So that's what this code will do in the future. Our password hash is going to have a random bytes 16 of length 16, and we're going to convert this to a string in hexadecimal format. Good. So this much for the models test. I also want to update the sign-up tests. And why am I doing it here? Maybe you don't like that I'm doing it here, but I will do it here anyway, because of course we should make our test pass here before we write the sign-up test. But I still want to continue with writing the test. I want to close this in this video, and then in the next video we will work solely on implementing the password hash class. Okay, so here I want to test that it encrypts the user password. Oops. When saving the user to the database. And now this is a somewhat more extensive test. It's not at the model level, this is at the route level, which means it's going to test since the beginning of the request until the end of the request, right? Not until the end of the request, but since the beginning of the request until the user is saved to the database. So first I need to send a request, await request to my app, and I will post in the signup route. I will send the valid user information that we already have available before. And here I will expect a 201, right? I will expect a 201 in the end. So this test should pass. So we should still see just one test failing here. Exactly, just one test failing, and you see that from 20 we increased to 21. So this test is being run and it's passing. But now the problem is, of course, const new user is going to be equal to await, and I want to find that user in my database based on my email. Why do I need to do that? It's because the password is of course not returned in our response, right? If we go a little bit to the top, or actually I remember where I put the test here for this one, but if I come to the, where is it? Events, I believe. Because in the events. Yeah, exactly. So here, whenever I have the user signed up event, then it does not include the password, right? So I'm not, when I serialize my response, I'm not including the password from the user. And maybe this would actually be relevant for us to add it here. So maybe I just forgot this. Should not include the user password on the response. So let's just do a quick check here. And then that will be the same. Const response, expect a 201. And then here I would expect response.body .password .to be undefined, right? So I don't want the password to be sent in my response. So now I should have 22 tests passing. 22 tests passing and one test failing. Exactly. So password is undefined. That's as we want it to be. Now for my new user here, what I would expect is to, well, actually we need to do a little bit of let's do a little bit of difference here. So if there is a password, right? So the problem is the problem with this new user is that if the new user may be undefined. So have a look at what Jest is going to tell us here if I simply write expect new user.password, right? Oops, it starts complaining about that new user is possibly null. So what I would like to do here is I will simply say const new user password, and it's going to be if there is a new user, which is going to be the case, right? And here the thing is that because I am creating the user via the request itself, it may be the case that the user is not created. So this that await user.find1 is not going to succeed, right? But in our test, we can ensure that this is going to succeed exactly, except if there is some problem, internal problem with Jest, but then we could kill it and try it again. I mean, it can happen, some unknown exception or something. So the new user password is going to be, if there is a new user, then I just simply want to define this as new user.password. Otherwise, I will mark this new user password as null, or maybe even as an empty string, right? So I would like now to, I would expect new user password dot length, and that's not a function, I believe, to be greater than 0. Right, so I want the length to be greater than 0, and I also would expect the new user password dot not dot to equal the valid user info dot password. So this test is going to fail, this test is going to pass, right? So let me comment this out just to show you that the first test is going to pass. So I'm going to have a password with a length that is greater than 0, but the second test is going to fail. Exactly. So now I have 2 tests failing, and the problem is this one, right? I expected the new user password not to equal the valid user information. So because I'm not encrypting anything, the 2 are the same, and this test fails. Great. So I think I cannot commit this because my tests are not passing, but I can at least run some prettier and some linting commands to ensure that my formatting is acceptable to the parser. Right, so I still have a couple of problems. Crypto should happen before, and that is in the user test model. So I just need to bring this up. Exactly. And then I have an unexpected unnamed function in my user.test in file 4. Okay, let's see what it's going to tell me now. Okay, line 6, I have an aha, yeah, so this should be something like this, right? The last thing I want to do is I just want to import these 2 guys. No, actually the base custom error is not being exported, so maybe we'll just export the base custom error from the /errors, and let's do a little bit of cleanup here. So in my errors directory, I come to index, and then I will export default as base custom error from /base custom error. And then here I need to come to the base custom error and mark this as a export default abstract class, and everything should work as expected, except of course that I need to change my implementation wherever I use this base custom error, right? So now I need to figure out where I use this, and of course I use this either in tests or in other errors. So here I will import base custom error from base custom error. Here I will also import base custom error from .base custom error. Let's see where else this is missing. So let me just run prettier quickly and then linting again. Okay, it seems to be working just fine, because I think that the only place where I used the custom error was within the user test here. So let me see where this is. I think that this to be instance of was the only case that I used within here. Great. So I think that that's enough for this video. It's already running quite long. I'll stop the video here, and I will come back. So we will come back in the next video to actually implement this password hash class. Until then, thank you very much, and see you in the next video. Bye bye.